Okay, so let's look at a task you might need to do with Ghidra. One of them is identifying functions. So one of the core things you'll be doing is looking at different functions that are running and trying to identify what the point of them is, right? So this lecture will make more sense once you've got hands-on with Ghidra a bit. So if you see the lab number 1 setup, it shows you some of the steps to actually open the same file. So as an example, if we take a look at a function here, what you can see is we have some function, we don't know what it is. So we have a function, we have the decompiled version of this function, right? We can see that it takes in a byte pointer. So this is like a char pointer, right? Or, oops, face is in the way there. uint8 or int8, sorry, pointer, or some sort of pointer, right? We don't actually know the exact type. We just know it's an 8-bit data type, right? So that's why it's called byte pointer here. And what you can see is, well, it's not equal to 0. Well, the value pointed out, it's not equal to 0. It just increments that pointer, right? So this makes it seem like for sure that this is some sort of string input, right? String input, because it's looking for a null terminated string. So right away we know this is a function that works with strings. What to do with the string is a good question. So there's a few ways we could kind of guess on this, right? We can see, number 1, that it's used in a bunch of spots. So we could look at all of these cross-references. So if we look at one of these cross-references, right, this is the one I used in the previous lecture, we could see that it's using these strings, and I see these strings printed over a serial port. Therefore, I actually could just know this must be the functions that's printing. So if I can find the string and find where that string appears when the device is operated, maybe it appears on an LCD, maybe it appears on a monitor, I now know what that function does. Okay, the other way, let's say you didn't have that, because sometimes you don't have any output that's really obvious, or the function doesn't take an input like that or something. So we have the other option. We go down and we see what happens. So if we look at this function, it was calling this 20fc, right? So we can open 20fc and we get this other function, and this function is just calling another function. So we just keep going down the stack. But before we go down further, we might look at what some of these constants are. So we have something here, that some sort of pointer off the stack. We have some constant values. So if we knew if those were some meaningful constant, that might give us a hint. In this case, it's not so. And we have this other dat thing. What is this? So this dat thing is a pointer to some constant or some variable or something. If we click on it, what we'll see is it's defined as this address here. So this is actually a global variable, right? So this is pretty common. What's happened is Ghidra doesn't know that this address is RAM. So it hasn't quite properly referenced that this is a global variable. So we don't see any other references to it. But basically this dat thing is a label. So this is a label. And it's just a default run, right? So it's a default name because it has no idea what it is. But this is actually a global variable that has some name when you compiled it, in your program. If we set up the memory map correctly, so to be done in lab number 1, we can find the references to all these variables. So now if I look, right, at this address to some zeros, 94, right, and H means H equals hex, so that's not part of it. So if we go to 20094, we now have this variable. So again, this is label for variable. And that's why the name doesn't make sense, because it doesn't know, right? It's just going to give it the default name. And we now see that this is referenced in some new spots, right? So we kind of had two separate things. We had this label here that was pointing to a spot in memory that then referenced our variable. And we also have some direct references to this same memory. So it gets a little bit confusing because there can be so many references, but you can see we're just going to keep following this stuff. So what we're going to do is we're going to look at these functions here. These are new functions. And if we look at those functions, we'll see something like this. So this is in that function, right? And we have that dat. So again, this is the thing that's of interest to us. And we can see it gets a little messy here, but if we kind of rely on Ghidra, if we do a bit of investigating, what we can see is that there's some sort of there's some other value that could be of interest here. And this maybe is like a constant value or something that's going to give us a little bit of a hint about what's happening in this function. So if we go here, right, so again, we look at what is this. This is defined as this value here. Now this probably doesn't, strike you as anything in particularly interesting, but what makes this interesting is that I kind of happen to know that on the STM32F3 device, that this device is, that's into the address space of the peripheral. So any of these 4000 is the address space of the peripherals. So if I look at the peripheral register map of one of the STM32F3 devices, I can actually see, oh, you know what? That 4001380 is US. So this address right here is the UART, right? So this is serial communications, right? That's good news. So that means we now have a guess that whatever this function's doing somehow, or sorry, not this function, but that variable that we started to look for, it's actually a UART, right? So this thing just holds, so we can rename these labels. So once we know what something is, we can rename the label to give it a lot more sense. And we can say, okay, that's actually UART1, right? So that's what it was there. This just holds the address of UART1, so it just assigns it to this global variable. Oops. Anyway, 1. I lied there. And so that function that we looked at earlier has some sort of looping over input data, and it's also connected to UART1. So that's a pretty likely chance that this is printing whatever input data we get to UART1. It's a bit of a guess, and you can see I just kind of had to keep following these variables, and lots will be dead ends. But that's more or less what we're doing when we're looking at all of this reverse engineering. So there's no exact formula for doing this, but the more sort of experience you get in this, you'll get a better feel for what type of functions are going to be what different tasks. What's going to make this a little easier is, and we'll look at in Lab 1, some scripts to help you automatically identify some of those peripherals. So we can use something called SVD files to automatically load some of these peripherals. So there's someone who's much better at Ghidra than me named Thomas Roth. He posts a number of tutorials under Ghidra Ninja. He actually has some trainings and other stuff, but he's released a tool that helps you get these files, load them into Ghidra, and actually show you what the addresses are. There's a few other ways that you can detect these functions. So you can detect like known functions, right? So there's certain functions that will be in a library and stuff like that. So you can actually detect what those functions are and try to automatically find them. So this doesn't work as well, or what I've seen on the Cortex-M devices. Desktop applications may have more standard libraries that are easier to figure out, but there have been people working on this as well. The sort of general statement, right, I'm going to make here is that tracing strings, so that's even what I did here. I started with a string and I saw where that was used, can be really helpful, because when you find a string, it's used in a function, it can tell you a lot about what it does, right? So if we have a string that's used in the default library, it can tell us that this function is part of the default library. You may see asserts, you may see error messages, and they're going to give you a feel for what the flow of the program is. If you use that in combination with the graph that I showed you earlier, this is a good way to start to understand what the program flow is and possibly what individual functions do. But yeah, so this will become a little more clear, I think, once you start experimenting with this, and that'll be one of the objectives of the first lab, is to actually experiment with Ghidra with a simple binary file that you can then analyze.